what all can cause noise? So we have seen IM distortion, intermodulation distortion, IMD. See, in the last class, we have seen what is IMD. The harmonic distortions will take the form NF, integer multiples of fundamental frequency. Intermodulation distortion will take the form, since we are sending a two-tone signal, it will be linear combination of these two frequencies, MF1 plus or minus NF2. This is going to be IMD, intermodulation product. Cross modulation is when your receiver is working across two frequencies. Those two frequencies are going to interfere. So these three things can provide noise to your LNA. Okay, so the intermodulation distortion, sometimes it is called as blocking. So what does it mean is, whenever two signals arrive at your receiver, one is going to be your strong noise, and another one is going to be your weak signal. Okay, so one is going to be your strong noise, other one is going to be your weak signal. In that case, this IMD products will block your actual signal. They will allow the noise to pass through and they will amplify the noise. So which is not desired reaction, desired property for us, because ultimately the fundamental signal, what is our interest, is getting blocked out. So that is one of the drawbacks of IMD products if they are present in your signal. Whereas if you consider cross modulation, it will change the frequency of your carrier. So if you are operating at one frequency, say 120 megahertz, because of cross modulation, the frequency will change to 125 megahertz, but the receiver will still look for signals only at 120 megahertz, but the frequency is changed to 125, so the LNA will not detect your signal at all. So one case, the weaker signal is getting blocked away because of IMD, and the second case is because of frequency translation, the signal is getting not detected completely. So if you want to eliminate these two problems, then we have to fix our amplifier operating in such a way that these two problems are being rectified. So that is the thing. That is why it is called as linearity and loss signal performance. Linearity, whatever input you give, without changing the frequency, it should provide the output signal. And large signal performance is whenever the amplitude of the input signal is going to be very, very large, the amplifier might tend to go to non-linearity. So it will automatically produce harmonic distortion NF. It will produce IMD products MF1 plus or minus NF2, and it will produce cross modulation products also. So that will happen when your amplifier slowly is entering the region of non-linearity. So we have to ensure that that is not happening in our system. So now we are going to develop some mathematical parameters to ensure that LNA is not going to block my signal, or it is not going to change the frequency of my signal. And more essentially, it is going to provide a very good noise performance, which means that even under noisy environment, my weakest signal is being identified and it is amplified properly by your LNA. So it is going to be actually very tough, but it requires some serious mathematical calculations to ensure that we can implement these two things for a low noise